Hello, this is Coach Meinbauer, and I'm here for AP Pre-Calculus. I'm going to go over a different unit that's what's on the AP curriculum. We're going to cover partial fractions, so it's going to be Unit M1, partial fractions, something that is typically in most advanced pre-calculus classes, but since we're AP, they took this out. I feel like it is important to put back in. This would be really helpful for techniques in using calculus stuff for next year for y'all. So I figured, hey, it's a good time to go over it. We'll go over some basic ones, some complicated ones, and maybe something in between. Okay, so what we're going to do here, the goal is to get one fraction into many fractions. Okay, and this is important to use in calculus because sometimes when we're doing something with a process, it's called integrating. It's easier to integrate separate fractions than it is one big old whole fraction here. So you can kind of see up top there what the decomposition of partial fractions looks like. What's really important here at the decomposition is to make sure that the power on the bottom is larger than the power on the top. Okay, so what we're going to do here is make sure everything is factored. And so I'm going to rewrite this as equals x plus 7 over, I can factor this as two things here. So this is going to be x and x. And this looks like 2 and a 3. So minus 3 plus 2. That will give me that factor down there. And what I want to end up doing here is I want to rewrite this x plus 7 over x minus 3, x plus 2. Rewrite this as a fraction. Since I have two factors on the bottom, I'm going to have two factors. So the power on the bottom is two factors. So we're going to have a over x minus 3 and plus b over x plus 2. You can go in any order you want, and the a and b will correspond with whatever the denominator is. So what we're going to do now is I want to rewrite this one fraction as a sum of two fractions, or maybe we're subtracting one of them, depending if b is negative or not. So we're going to get rid of all of the denominators by multiplying everything in blue here by x minus 3, x plus 2. And what's going to happen here is on the left-hand side, we're going to cancel out, and you're left with just an x plus 7 equals, for the a fraction, just the x minus 3 cancels out, so we're left with a times x minus 2. And then for the b fraction, the x plus 2, sorry, there's b plus 2 right here. And for the b fraction, the x plus 2 is canceled out, so I'm going to get plus b x minus 3. So really, that's the hard part. Now all we have to do is figure out what a and b are. There's a couple different techniques. If you look online, you'll see different techniques. I use the elimination technique, and what that means is I pick specific x values to plug in to eliminate the variables of a's and b's. So I'm going to pick x equals negative 2. And I picked that for a reason, and let's see if we can kind of pick up why I did as I do this problem. If I plug this x equals negative 2 into this equation, the left-hand side becomes 5 equals, when I do the a term, I'm going to get negative 2 plus 2, which zeroes out, and that cancels the a. And then for the b term, I'm going to get negative 5b. Can you see why now I picked negative 2? Very good, because we want to cancel out the a or b terms or factors. So if I divide that over, b is going to equal negative 1. I already got one of the letters. So what do you think the next best number to pick is? If you chose 3, you chose right. You can really choose anything. It's just more work if you choose it. Like if you choose x equals 0, that'll work. It's going to take a couple more extra steps to get where you want to get to. So I'm going to get 10 equals, that's going to give me 5a. And then the b term is gone. So I'm going to get divide both sides by 5. I'm going to get a to equal 2. So now I have my final answer now. I'm going to get, I'll write it in purple here. So I'm going to get a over x minus 3 becomes 2 over x minus 3. And then minus 1, because b was negative 1, x plus 2. And there we go. So we decompose this one fraction into two fractions because we had two factors. Okay. So now that we kind of got the idea of what the heck is going on here, I can probably poke up here and show you a couple other things here. If we have repeated linear factors, which is going to come up soon, what we need to do is we need to repeat our factors within our fraction, and you'll see that here in a moment. If we have quadratic factors, which I don't think is in the notes, but it may or may not be in the worksheet, that's how you set it up. You would set it up with the quadratic factor on the bottom with an ax plus b on top. If there's several of them, you'll do more and more. So just try that one out for fun on the worksheet if we have one of those. All right, example 2. This is already factored, super nice for us, but the only problem is we're going to have several factors here because I have a power 3 and then a power 1. So I'm going to have 4 total fractions here. So here we go. Let's go ahead and set this up. So I'm going to get x squared plus 1 all over x minus 1 cubed. And that's going to equal, I'm going to have, like I said, 4 of them. I'm going to go a over x. That's not repeating, so I just need to put it one time. Plus b over, we have x minus 1 repeating, so we need x minus 1. And then we need every factor until we get to 3. So x minus 1 squared. And then plus d, x minus 1 cubed. So since we're repeating the x minus 1, I have to have as many repeats as we have. So starting from 1 up until we get to our repeat. Okay, and then once we're here, I'm going to multiply everything by what my LCM is here. Least common multiple, if you didn't know what the heck that meant. So multiply everything by x, 1 minus x minus 1 cubed. So now that's going to produce just an x squared plus 1 equals, for the a term, the x's cancel out, and I get a x minus 1 cubed. For the b term, just one of the x minus 1's cancel out, so I'm left with x minus 1 squared. For the c term here, I just have 2 of those cancel out, so I'm going to get c x minus 1. And for the d term, I just have plus dx. Okay. Now, this is going to be a little bit more work here, but we'll get it done. So first off, pick 2 x values that are super easy to work with. Since we need to solve for a, b, c, and d, we'll need to pick 4 x values. It will get a little muddy, but that's okay. That's what we're here for. So I'm going to first pick x equals 0 because I see if I plug in a 0, the d term is going to go away. So if I plug in a 0 on the left-hand side, I'm going to get 0 squared plus 1, which is just 1. And then that's going to equal, for the a, I'm going to a times negative 1 cubed. And then the b term, it turns into 0. The c term turns to 0, and the d term turns to 0. So I'm actually going to end up with 1 equals negative a. So a is negative 1. So there we go. 1 for 1. The next number that's going to produce some zeros here is if I pick 1. So if I choose 1 on the left-hand side there, I'm going to get 1 squared plus 1, which is 2, equals, the a term is x minus 1 all cubed, so the a term is gone. The b term, same thing, gone. The c term's gone. So I'm going to get d, which is pretty straightforward. So I have a, I have d. Okay, so I'm going to kind of put a little squiggle here for the next round of things. So I have this. I have this. This is fantastic. Now, unfortunately, there is no other number to plug in to just cancel everything out. Because since I only had 2 unique factors, those are gone. So I just need to pick other numbers. So I'm going to pick just I think a 2 is not hard to work with. So if I pick a 2, I'm going to get 5 on the left-hand side. And then I'm going to get a equals a plus 2b plus 2c plus 2d. Okay, so now I have four variables. What's really nice, though, is I already have a couple of these. So if I can plug in the -1 for A and then the 2 for D, so that would turn into a 4. And then just everything else drops down. So unfortunately, I kind of have to pause here on this one. There's nothing else to do here. I will set this up as a system of equations, though. So if I subtract 4 from both sides and then add 1 from both sides, let's see what I get here. I think I get 1 equals B plus C. So I'm going to subtract 4, and so I'm going to get 2 equals 2B plus 2C. Divide everything by 2. I'm going to get 1 equals B plus C. So if I find B, I can plug it into here to easily find for C. Okay, fantastic. Let's go ahead and use the next number. You can pick really anything you want. -1 might be a good option. I did not pick that. I picked 3. It's easier for me to stay positive. So I'm going to get 10 on the left-hand side because 3 squared plus 1 is 10 equals, and then I'm going to get 2 cubed, which is 8a. Great, because I already have a, so not a big deal. Plus 3 times 2 squared, I got 12b. And then I'm going to end up with 3 times 2, so 6c. And then plus 3d. If I plug in for those values, because I have a is -1, that's going to give me -8. And then for the d, that's going to give me a 6. And then everything else is just going to drop down. Okay, so all left is b and a c. When I solve for this, just checking my work real quick, making sure I'm good to go. I'm going to get 12 if I subtract 6 from both sides and then add 8 to both sides. I'm going to end up with 12 equals 12b plus 6c. So divide everything by 6 here, make this a little bit nicer. Okay. 2 options. I can use elimination or substitution. Since I have a system of equations here, I think it's pretty easy to just go c is equal to 2 minus 2b. Once I do that, I can come in over here, kind of use this equation right here, and come in and plug it in right here. And I'm going to get 1 equals b plus 2 minus 2b. So what does that give me here when I solve for this? I'm going to end up with -1 equals -b. So b is 1. Since b is 1, plug that in. I'm going to get 2 minus 2 times 1 for c. So c is 0. So now I have b is 1. I have c is 0. And now I am done. So the heavy lifting needed to be done there to find b and c. So if I write down my final answer, this is equal to a, which was -1, so -1 over x. The b, which is 1 over x minus 1. The c is 0, so I'm just going to just 0 at that term. So there is no, I'm not going to write down 0 over 1 or x minus 1 squared. I'm just going to keep it at 0, and then plus 2 over x minus 1 cubed. Okay, that'll be that answer. Things are looking good. That's the hardest one of the whole. Just if you're curious, it's a little bit of work there. I get that. System of equations, nobody's favorite. So last one here, find the partial fraction decomposition of this guy right here. Now this one's a little bit different. If you look back up here at our rules, we need the degree of the numerator to be larger than the degree of the. We need the degree on the bottom to be. I'm just reading this. I'm sorry, I'm reading through it kind of incorrectly. If the degree on the numerator is larger, then we need to use long division because the bottom needs to have a higher power. As you can see there, for example 1, bottom had a higher power. Example 2 here, power on the bottom was 4, so I had 4 fractions. but it was larger than the numerator. And if you look at these powers, they are the same. So we're going to go ahead and use long division, reteach that one. So we're going to go ahead and do x squared minus 2x. And then we're going to divide that into 3x squared. Oops. Oh no, we were doing so good. The technology working. It's going to start to shut down on me here. So long division, we have learned that previously back in Unit 1. So what goes into x squared to make 3x squared? Well, 3. So we're going to get 3. So this is going to give me 3x squared. Multiply that through minus 6x. And then we're going to subtract all of that, which means we're going to change that sign in the middle. So I'm going to get 7x minus 4. So this is actually the same thing as 3 plus 7x minus 4 all over x squared minus 2x. We divide by, it stays on the bottom. Okay? So now I need to do partial fraction decomposition just on the 7x minus 4 over x squared minus 2x. So here we go. Let's go through this process now. So let's go ahead and factor that. So I'm going to just focus on just this part, and I will put the 3 at the very, very end if we're okay with that. We kind of have to be because, So I'm going to write this as 7x minus 4. And the bottom does factor. Take out an x. I'm going to get x minus 2 because I have power 2 on the bottom. I'm going to have just two fractions. So a over x plus b over x minus 2. And what we're going to do, multiply everything by the LCM, which is x minus 2. Please come multiple. And that's going to give me 7x minus 4 equals a x minus 2 plus b x. Now at this point, I think it'd be wise if you were to pause the video and then solve for this on your own and see if you match up with my answer. So I would pause the video now. Oh, welcome back from your paused video, and hopefully you did the work. So I'm going to go through right over here, and I'm going to try to squeeze it in right here. I'm going to let x equal 2. When I do that, I'm going to end up with a 10 equals 2b. So b is 5. Let's divide both sides by 2. Now let x equals 0. I'm going to get negative 4 on the left-hand side equals negative 2a. So divide both sides by negative 2. A is 2. So my final answer here is going to be, I'm going to write this in purple, is going to be 3 plus, and we have a, which is 2 over x, plus b, which is 5, over x minus 2. What an exciting time to be alive here to do partial fractions. And that is going to wrap up our video. Do not forget to like and subscribe.